So we talked about elements, then we talked about compounds, and I want to talk a little bit more about mixtures. To kind of put things in perspective, this is that, I should ask some questions over this on your test, shouldn't I? Matter can be either classified as pure or a mixture. And if that matter is pure, that means that you must have either an element or a compound. Remember, we talked how actually you can break compounds down into their elements by chemical reaction, and you could build elements up into compounds by chemical reaction. But now I want to focus or remind you how this works, that we have mixtures over here, which is two or more pure substances that are just physically combined. So the cool thing about that is that mixtures actually can be basically unsorted one way or another, some it's easier than the other, unsorted back into their pure substances. One of the things I also want to make sure we're all on the same page is this idea that there are two types of mixtures, and I think I mentioned this before. We have homogeneous and heterogeneous mixtures. In both cases, you have two or more pure substances that are just kind of tossed together. If it's well mixed, remember I wrote that before, well mixed, we call that a homogeneous mixture. And if it's chunky, okay, then it's not the same throughout, it's not uniform, it's a heterogeneous mixture. So if I were to throw these two at you, hopefully you would kind of tell me that the fact that, does this guy look chunky over here? I hope so. You can, if you're looking at this in color, you can kind of see some tan specks and some black specks. And if I sample here, for instance, right up here, I'm going to get a different ratio of white to black specks than if I sample down here. So it's not the same throughout, it's heterogeneous. And then over here, this actually probably, what? Students would maybe tell me water, and then there's something to make it blue. Something else. Okay. Even if you put like food dye in water, you have created a mixture. You have the water molecules, and then you have the dye molecules. And if you have swirled it up, and it's pretty much the same throughout, it's a homogeneous mixture. So another important mixture I want to kind of point out, maybe not so much for us in here in the Midwest, but we have a picture of, let me put this whole slide up here, and then I'll explain what I was trying to say, what's important about it. But so like I said, just to kind of recap, the substances can be broken, of a mixture can be broken back out into their piles of pure substances. So they actually retain their own, they don't get changed in any way. So, for instance, a water molecule that you've added dye, which is mixed with dye, is still a water molecule. So another thing about mixtures, and I didn't mention this before, is that you can kind of pick how much of each pure substance you want to have. So you get to set the ratio. So if you get to set the ratio, that means the ratio is not fixed. So the ratio can change a lot. The example I use is if my daughter makes Kool-Aid, she likes it really sweet. So she puts a lot of sugar to water. And if I make Kool-Aid, I like it kind of tart. So my ratio of sugar to water is less. Let's see. All right, so we can go back with the Kool-Aid. The properties or the way it tastes will vary depending upon how much sugar I've added. Let's see, and I think I did mention this one. If you have a mixture, you can break it back out into its separate components just by some sort of what we call physical process. Physical processes would include like sorting or filtering, but no sort of new substances, no sort of chemical reactions need to occur in order to separate them back out. So here's a figure from your textbook, and it has two mixtures. Here's a mixture, it's air, and here's a mixture down here, it's water. So what your author has done is up here, should have picked two different colors, shouldn't I? Up here is the mixture of air. I know it's weird, but we just have gas particles. I would call that, what, a homogeneous mixture? Air that we're breathing is about 80-20. It's about 80% nitrogen and about 20% oxygen. The other mixture is, and I guess it would be homogeneous. I'm not real familiar with oceans as much as maybe some. But oceans, of course, are seawater, salt water. And so here what your author has done is to show those cute little water molecules that are they look like Mickey Mouse, the middle oxygen atom and the 2 hydrogen atoms on either side. So, and then actually these are the ions. I think we talked about compounds and we said if you have a metal in your compound, like salt water, sodium chloride, if you have a metal, then that is an ionic compound. And one of the things that ionic compounds can do, there's different degrees of solubility, and we'll talk about that, but sodium chloride actually dissolves in water, is my point.